Hello, this is Juan Blanco from Ethereum. Today I am going to try to explain further topics around the Ethereum and how to integrate it with Ethereum itself. So we will be talking about calls. We'll expand about calls. We will talk as well about transactions and events, filters, and topics. Calls. In the previous sessions, we did a multiplication call to a function that was defined in a smart contract. As we can see here, this is our previous multiply function, which is it was using a parameter to an equivalent multiplier to return a value. So calls mainly allows us when interacting with Ethereum to call functions and return a value. The difference from calling a function within a transaction is that but they are they are not mine. They are not mine or verified by the consensus. So a transaction, it is a call to maybe the same function, the multiply function that I have seen before, but it is verified by the consensus. This means that it will use some gas, as it will need to verify by the participants in the network, and it won't return any value. So if we call the multiply function through a transaction, it will spend some gas and we then see the result. So what happens if we want to know what has happened in the specific function? Then we can use events. We could also store the value in the contract itself and into a public variable, or we could just have another getter method that we could use with a call and get the value from net, but in a simpler way. And if we don't want to spend any gas or any ether storing this data within the contract itself, we can then use events. So events, what it does is put information on the log. You can retrieve the log information if you have fully synchronized your chain, and you can using an Ethereum client or something like Ethereum to retrieve the log. Let's see, the client. So mainly the logs are stored in an internal database that is synchronized based on the transactions, but they are not verified by the consensus. So filters, as they don't really live in the chain itself. Filters. So how we how we retrieve a specific information for a specific event. We can create filters, and which will mainly give us information for give us the whole information of the event has raised, for maybe from a block number to another. So passing the from a block to the latest block. So we can use filters to get the event, data for a block to the latest block. And once you create your filter, then you call it, and it will bring you data back, and then you can use it to pull out the changes that has happened. See, that just call the filter. So the client keeps a track based on your specific filter ID of the any changes that have occurred since you called the previous one. So that's very helpful, as you don't have to keep track of what you have done. But this is all good. But what if you want to filter for a specific values that are raised in the event as that are part from the event? Then you can use topics, and topics to, for example, match the address that was the part of the event, or a string, or an integer. So topics are the index values that you can filter further the log. So this is mainly what we'll be covering today. So what I have done, just to get this a head start, I have copied the deployment folder that we had originally, and I have moved it to called transactions events folder. And here I have created the same class with a new unit test, which already have our standard address, our password, ABI bytecode, and our constructor, and an instance of Web3 locking the account. We're deploying the new contract that we are going to create here. The only difference is that I have created a new method, well, refactor a method, which is mine and get reset async, as we will going to do this a couple of times. So our code does not it's not as smelly. So let's get started. So if we head to our original contract test, now what I want to do is put an event in here. Okay, so we're gonna call with a transaction our multiply function. So I just want to retrieve some information of this transaction. Probably might be probably it might not be as a very useful event, especially as we're using the multiply function, but it will be good for this demo. So let's try create an event. So use our auto complete here, and then we'll call it multiplied. So something has been multiplied. We're going to capture in this event maybe the parameter, and we can also well, the sender address, and the result. Okay, but we are also going to demonstrate how to filter using topics. So we are going to index in the input parameter. So I is going to try to see if I can only get the logs for this event that match a parameter value, and could do the same for the sender. Okay, so let's modify this so we can return a value, send the multiplied event, and let's pass the input parameter, the message sender, and the return value. And after that we can return the result. So if we save this and then we compile it, to access this menu, shift command P in a Mac and F1 in a PC. We can then compile the current Solidity contract. We have a result which is spotted, and let's try again. Cool. Right, so now our contract has been compiled and it is here in our bin folder. You can see the ABI and our bytecode. So let's copy this bytecode and put it into our new test class. Prefix it with 0x as it is a hexadecimal, and we're going to put the ABI as well. We need to do some formatting here, and let's move it to our text bar, and I got one here already. And what we can do, instead of replacing it for doubles in inverted commas, is just do apostrophes. As it will be more readable, and you can make it more portable. So we got our ABI, we got our bytecode, and we have our, if we step down here, we have here our original multiply function, and now we're going to get as well our multiply event. So to do so, we use our contract again, but instead of calling get function, we'll get event, and we use the multiplied. Okay, so now we got the multiply and the event and the multiply function. Next step will be to let's submit a transaction to do a multiplication to the contract. So if we use our original transaction as variable, we can now call multiply function, and instead of calling async, we're going to send transaction async. And now we need to pass the sender, as this will be charging us some gas. So we pass this sender address and something to multiply by. So as before, let's use 7. And we're going to submit 2 transactions, as we are we want to see different logs being captured. I am not really going to use transaction hash, hence I am just assigning them at the same time. In a similar way, I am going to use our mine and get receipt to mainly to get the receipt of the latest transaction hash, to confirm that the last transaction has been mined. So just to be able to get the logs and so okay, so we have sent these two transactions. We know they have been mined. Let's now create a filter. So to create a filter, we can just say filter equal multiply event. So we need to await it, as we were going to call the client, and we're gonna create a filter async. And that's it. This filter, what it's going to do is gonna capture every event that is a multiply event for that specific contract. So just to give it a better name, it's called a filter all, as we are going to create now another filter to demonstrate the topics. And we're going to, as we may remember, we have created a multiplied event here, and we have index a, which it was our input parameter. So let's put a filter for one of our input parameters. Let's see if we can retrieve that. So let's try to get a filter for 7, and we pass that as the input. Okay, so we have now two filters, and we will want to retrieve the logs. So let's do a log for all. So using our say multiply event, it says we can do get filter changes. Okay, get filter changes will retrieve any changes that has happened since you created the filter up to here. Okay, so we can pass the filter all. Of course, no changes might have happened in these two lines, well, this single blank line. So what we can do is move this to before. So let's undo that, as I haven't copied correctly. Move it before the time that we submitted the transactions. So now, because we're gonna get all the changes, we create a filter before we submit the transactions, and transactions get mined, and now that they have been mined, we can get the filter changes. So we will be able to get anything that has happened since we created until here. Okay, and if we call it again get filter changes and we submit the transaction in between, we will get only the transactions that happen in between. So this is our get filter changes, but we need to be able to decode this information. To decode the information, when we have complex returns or complex input, if you wanted, we create DTOs. In this scenario, we are gonna create the event DTO. If you have a complex output, you can create a function output, and I will show you very quickly after I create the event DTO to demonstrate you how to can do the same. So let's create our new class. We call it multiplied event. Okay, so this is a multiply event, and it's gonna contain all the attributes that are passed as part of the multiply event in the contract. So if you look at it, you have a and then sender and the result. This information is part of the API, but as we know it, we have created. It's more readable this way. Let's just put it here. Okay, so we need to create an attribute or a property that will match our parameter A. So we can use the parameter attribute, and we will pass the type. In our scenario is an int. Then we can pass the name. Then we're gonna pass the index of the parameter. So in this is time is 1, and finally if it's indexed or not. Okay, so now we got this here. We can create our the property for A, which it is really the multiplication input, and that's it. And we do the same for the other ones. So just copy and paste this here. The next one is going to be a type of address, and is the sender, is the second parameter, and we're going to call this sender, and it is an address. So an address can be decoded as a string. So we're going to put a string as the decoding type. And finally, this view as the next type is an int. We copy the first attribute, a property which is not indexed, and is the result, and we call this result. And this is it. We have a class now that can be decoded as the event output, as a type event output. This works very similar as we use parameters as well to pass complex, to have a complex output. So if you put a complex function output here, and we have multiple parameters out, it will work the same. Obviously the indexing is not necessary in this scenario, but we have the parameters orders, the type, the name, and so on. And if we want to have a pass a DTO as a function input, it was the same. So we can have this decorrected as a function input. And that's it. And we pass the name and so on. So now we have our multiply event. We don't need to decorate this class with any attribute as the output. So now we've created our event DTO. We can use the generic method to be able to decode it. Now, in a similar manner, let's try to get the logs for any changes that has happened since we created this log, or since we called it the last time, for the multiply event filter 7. Right, so now we got these two. Let's do some assertions. So what do we expect? Do we expect, since we've done 2 transactions here, I expect to have 2 as the count of the logs. Yep. And I expect to have 1 as the log count for 7. Then I will also expect that the first item of the log count, of the log 7, the input parameter will be 7. So if we get log 7 and we get the first one, which will be the only log that we have, if we look at the event, which is this, the input will be 7. And also I would expect that the result of the multiplication will be 49. If we look at the log as well, we can see that there are other information here that we can capture. So you got the address, the block hash, block number, the data, the topics, and so on. The topics have encoded. Hash, index, etc. So now we've got this open running. So the next step will be to see if we got get running. And let's clear this, and we don't, so let's remember. So it is a start get to start our small private chain, clear all the data that we have before, start from fresh from start from scratch, and let's start. We got the breakpoint here, so start the debugging. Once the debugger hits its breakpoint, let's remember what we have done with our test. And so we have created a multiplied event which is going to output the results of is going to output the result of our multiplication. It's going to include the sender who has done the request to perform the multiplication, and it's going to output as well the input parameter, which is in our scenario A. So when we multiply by 7, will output 7, it will put our address here, and because we pass as the constructor the multiplier 7, it will be, the result will be 49. And it seems that it has not started debugging successfully, so let's start again. And wait till it hits the breakpoint. Okay. So we've done the overview of what we have done before. Let's play the contract. So let's just so we go to sender address, reconfigure our password. We have our ABI, have the bytecode. It passes the multiplier constructor 7. We have the default Web3 configured with HTTP localhost 8545. We unlock our account this time for a couple of minutes to be able to do all these transactions. We deploy our contract. This will give you a transaction hash, and we wait for the contract to be mined. We get the receipt, the contract address from the receipt, and then we get the contract wrapper. We get the multiply function, we get the multiply event, and before we submit transactions, we create a couple of filters for that event. One to get all the events that are raised by the contract matching that event itself, and another one for that event itself in the contract, but when the input parameter is 7. We have created both two filters. We got the transactions transaction hash by submitting both transactions, and then we wait for the last transaction to be mined. So it means that both have been mined. Now that we have the receipt of the mine transactions, we know that the logs is going to contain this. So we have the first log, the first set of logs, and we have in here two, which one will be for the multiplication input of 8, and the other one will be for the multiplication input of 7. And we got also the results 56 and 56, and we have as well our address in both. And 7, we should be returning only one log, and it will be for 7. So if we continue, you see now our assertions pass. Okay, thank you very much. I hope this has been useful. We have covered in this session a quick introduction about the difference between call, transactions, and what are events, and then we have modified our multiply contract to be able to raise events and then capture the logs produced from this event using .NET with the help of Ethereum and Visual Studio Code in a cross-platform development environment using a Mac. Okay, thank you very much, and goodbye.